Hi there. Let's get started with the solutions to our trigonometry Unit 6 practice test, a little unit summary action here. So here's the Ferris wheel problem again. Give you the specs on the Ferris wheel here. 30 seconds rotation, 45 feet above the ground. The diameter of the wheel is 70 feet. This is the equation here that represents the height of a position on this wheel past this point A here as it goes around counterclockwise, just like on our example problem in this unit. This is the equation here. The 35 is the amplitude, all right, and it represents the radius of the wheel. The diameter is 70, so that means the radius is 75. The plus 45 here is the number of feet above the ground for the center of the wheel, and this pi over 15, that is calculated from 2 pi over 30. 2 pi over 30 is the period of sine function divided by 30 seconds. So the rotation of the wheel here figures into this number. More accurately, this is called the angular velocity, and it's the input value into the sine function. With that explanation going, we're going to change some of those numbers and write a new equation. So now the wheel makes a revolution every 60 seconds. So that would be 2 pi over 60, which is pi over 30. The radius of the wheel, the new wheel, is 30 feet, and it's still 45 feet above the ground. So 30 times sine of pi over 30 times x plus 45. Both of those equations can be graphed down here. This first one that I circled in pink, that's this shorter one right here. It's a taller wheel, and it's also rotating faster. It completes a revolution in 30 seconds. So on my axis here, I've got 30 seconds marked out like this. 45 feet is the center of the wheel, so you can go up as high as 45 plus 35, which is 80 feet, and you can go down as low as 45 minus 35, which is 10. So that's the low point and the high point right there. 10 feet for the low point and 80 feet for the high point. The other equation right here, which is a smaller wheel, the radius is only 30 feet, so from 45 it only goes up to 75 feet at the highest point. And it completes its revolution in 60 seconds, so stretched out a little bit here on the x-axis, and that curve looks like this, that they cross this same point right here at 30 seconds. And so that's what the graphs look like. Okay, let's flip it over. Here's some more graphs, and on all of these you're just supposed to figure out the equation basically by breaking it down kind of piece by piece. So you can look at this graph here. Let's get a little closer. The amplitude is the distance away from the midline. That's one way to think about it. Another way to think about it is the total distance, vertical distance, divided in half. So it goes up to a high point of 8 on the y-axis and a low point of -4. So that's a total distance of 12. 8 minus -4. So you take that divided by 2, that's 12 divided by 2 equals 6. So that's the amplitude. And it's also true that the amplitude represents the distance away from the midline, the highest and the lowest points. So 6 units above and 6 units below. The period on this graph, you can see that it makes one complete cycle right there at 2 pi, and so that's the period, and the k value in the equation is always 2 pi divided by the period, which is also 2 pi here, kind of a coincidence, but that means our k value is just a plain old 1. And the vertical shift, that's the number halfway between the highest and the lowest point. That works out to be a positive 2, and so that's our vertical shift, so our equation is right here, 6 sine x plus 2. Next one is a upside down sine curve. Notice that it starts from the midline and goes down, so you should have a negative sign in your equation. But anyway, the amplitude, it goes from from 0.5 to 1.5. That's only a distance of 1 unit. So the amplitude is just 0.5. The period on this graph, it makes one complete revolution right about there, and so that's pi over 3, so that's our period. And here's the tricky part, 2 pi divided by pi over 3. You can work that out kind of step by step by taking 2 pi, multiplying by the reciprocal of that fraction, which is 3 over pi, and then the pi's cancel out, and you just end up with 2 times 3, which is 6. So that's the k value in the equation. The vertical shift is positive 1. That's halfway between the highest and lowest point. So there's our equation, negative 0.5 sine of 6x plus 1. The last equation on this page is a cosine curve, and cosine curves always start at the highest or the lowest point. This one starts at the lowest point, so it's negative cosine. So let's get that figured out right away. The amplitude, when you work it out from 20 to 50, is that's a distance of 30, so half of the 30 is 15. So there's our amplitude. The period is 2. You can see here it goes up and then back down to the beginning point again at x equals 2, so that's our period. And 2 pi divided by 2 for our k value is just plain old pi. The vertical shift is halfway between the lowest and the highest point again, so halfway between 20 and 50 is 35. You can figure that out in a couple of different ways. Just mention one way is to take the amplitude and add it to the lowest point. If the lowest point's 20 and the amplitude's 15, then the vertical shift is 20 plus 15, or 35. So there's our final equation there, and that's all we're going to do on this page. Stay tuned for the next video on the other page. Bye.